Hi, in this video I'll help you get to know your car a little better. At the end of this video I've put together a straightforward infographic that summarizes all the key points. Like, subscribe and comment below. It really helps.
Imagine this. Your check engine light flicks on. Your mechanic runs the codes, comes back with a long face, and hands you an even longer estimate. He's talking about replacing multiple super expensive parts. But what if I told you the real problem costs almost nothing to fix, and you're about to make a $2,000 mistake? All right, let's get into it. You know that feeling, right? That dreaded little orange light pops up on your dash. You're praying it's something simple, like a loose gas cap. But then the diagnosis comes back looking like a complete and total system meltdown. It is confusing, it's incredibly stressful, and you can just feel your wallet getting lighter by the second. So, at first, the computer spits out this absolutely baffling list of error codes. You've got a general injector circuit fault, a fuel pressure sensor fault, a fuel temperature sensor fault, and a cylinder misfire. I mean, this is where most people's eyes just glaze over. But the first question you've got to ask is, how on earth could all of these different parts fail at the exact same time? The odds of that are just, well, basically zero. And you know what? You'd be absolutely right to be skeptical. The answer is almost certainly no, they did not all fail at once. The real culprit is probably a single, really simple issue. And the best part? The fix might literally cost you nothing but a little bit of time, saving you from a whole cascade of expensive and totally unnecessary repairs. But then, just when we're trying to figure out this mess of confusing codes, a brand new piece of information comes in. And this one changes everything. Think of it like a detective story. This is the key clue that's going to crack the whole case wide open. The computer logs a brand new code, P0202. Now this is specific. It's pointing to an open circuit on the injector for cylinder number 2. This is the breakthrough we needed. See, having this one specific code on top of all those general faults creates a very, very distinct pattern. It's the key that's going to unlock this entire mystery. So, with this new clue in hand, let's jump into our first section. It's time to unmask the real culprit, and we're going to start by getting rid of all the obvious but wrong suspects. So, a mechanic might first think, maybe it's a bad fuel pump. But that doesn't make sense. A fuel pump failure wouldn't cause electrical circuit faults. Okay, what about the fuel pump driver module? Well, that controls the fuel pump, but a failure there would affect all the injectors equally, not just a specific one like cylinder 2. And, like we already said, the chances of multiple sensors and injectors all breaking at the same time are just astronomically low. We have to be looking for a single point of failure. So after we eliminate all those possibilities, the evidence starts pointing overwhelmingly in just one direction. We are not looking at a bunch of broken parts. Nope. We are looking at one single, system-wide electrical fault that's just making it look like everything is broken. And that brings us right to the real culprit, a failed or corroded common ground. You know, think of it like the foundation of your house. If that foundation cracks, you're going to see problems in a bunch of different rooms. Well, in your car, all that electricity needs a clean path to get back to the battery. That's the ground. And if the one single ground connection that all these injectors and sensors share goes bad, it can't provide a stable electrical path. And boom, they all start reporting errors at the same time. Okay, so we're pretty sure we know what the problem is. Now, what do you actually do about it? Let's move on to section 2 and build a clear, step-by-step action plan. All right, first things first, and listen up, because this is probably the most important piece of advice in this entire explainer. Do not, I repeat, do not let anyone replace a single part yet. Before you spend one single dime on new components, you have to do these simple checks first. Step 1, we're going straight to the source of our biggest clue, that injector on cylinder number 2. You're going to back probe the connector. Now, that sounds fancy, but it just means carefully sticking a multimeter probe into the back of the connector while it's still plugged in. This lets you see if it's getting the 12 volts of power it needs, and more importantly, if the computer is sending the little electrical pulse that tells it to fire. If either of those signals is missing, you've confirmed it's a wiring issue, not a bad injector. Step 2 is the big one, and thankfully, it's the cheapest. You need to find the main engine grounds. These are the big, heavy cables that connect the engine block to the car's frame. Disconnect the battery first. Then, take every single one of these grounds off, clean the contact points with a wire brush until they are shiny, and then tighten them back down securely. I'm telling you, there is probably an 80% chance that this step alone will solve everything. Now, why are we being so pushy about checking the grounds first? Well, because ignoring this step leads us right into Section 3, a really costly mistake that you absolutely have to avoid. Look, if you just start throwing new parts of the problem without fixing that bad ground, you are literally setting your money on fire. A bad ground causes crazy voltage spikes and unstable power that will destroy the brand new components you just paid for. The problem will come right back, and worst of all, you could permanently fry your car's main computer, the powertrain control module, or PCM. That's the brain of the whole operation. And how much does that little mistake cost? Well, a new PCM, plus the labor and the special programming it needs, you could easily be looking at over $1,000. All because a simple ground wire wasn't cleaned and tightened. And it's not just about the money, which is bad enough. A bad ground forces electricity to find other ways to get where it's going, unintended paths. This can make wires overheat, melt their plastic insulation, and create a very, very real risk of an electrical fire under your hood. The severity here is absolutely extreme. So all of this brings us to our final section, which really just frames the whole situation as a very clear choice you have to make. This is the $250 fix versus the $2,000 disaster. To make sure you end up on the right side of that choice, we are literally giving you a script. Walk into the auto shop and say this, word for word. This language is specific, it's confident, and it tells the mechanic that you know what you're talking about. It directs them to check the simple, cheap fix first, before they even think about throwing expensive parts at the problem. And here it is, the two paths laid out right next to each other. Let's look at the left side, the correct diagnosis. The problem is bad grounds. Your parts cost is 0. Labor is maybe an hour, 2 tops. Total bill? Maybe $100, $250. Now look at the right, the misdiagnosis. You start replacing injectors, sensors, maybe even the PCM. Your bill skyrockets to $2,000 or more. And guess what? The original problem might still be there. So the next time your car throws a whole bunch of confusing electrical faults at you all at once, just take a breath. Don't panic. Remember, the simplest explanation is usually the right one. Before you authorize thousands of dollars in repairs, remember the most powerful and the cheapest first step you can possibly take. The fix is in the grounds. You always start there.